Welcome to the world of TrendPod AI. So much to do, but hardly enough time. Isn't that how you often feel? You're just, racing through the week, trying to cram everything in, and it feels like the days just sort of vanish.
Well, what if I told you that feeling might actually be literally true? What if the Earth itself is speeding up, making our days just a tiny bit shorter? Welcome to the deep dive.
Yeah, it does sound a bit like something out of a movie, doesn't it? But it's real. We're talking changes measured in milliseconds, though. So really, really tiny. You wouldn't feel it.
Right. It's not like you're suddenly losing minutes or hours.
No, definitely not.
But even though it sounds minuscule, this whole thing, the Earth's rotation speeding up, it's actually, it's causing a bit of a stir among scientists.
Especially the ones managing our global timekeeping. Exactly. So today our mission is to figure out, why this is happening, what factors are involved, and why this super small shift is actually kind of a big deal for the tech we all rely on. So let's put some numbers on this. Earth is spinning faster lately. We've had some record short days, like July 9th recently. That was 1.23 milliseconds shorter than the standard 24 hours.
Mm-hmm.
And then July 10th was even shorter, 1.36 milliseconds less. That made it the shortest day this year so far.
And there was another one anticipated, right? August 5th.
Yeah, essentially shorter by about 1.25 milliseconds. It's becoming a pattern.
And what's really fascinating here, I think, is that we think of a day as being, exactly 24 hours, 86,400 seconds on the dot. But the Earth's rotation, it's naturally a bit wobbly. It's rarely precisely that length. It varies.
And this isn't just a one-off thing, is it? Since 2020, we've seen a whole bunch of these record-breaking short days.
That's the key point. Before that, for decades, the shortest day record was, about 1.05 milliseconds short?
Right, and now we're seeing days that are significantly shorter than that old record. Last year, July 5th was the shortest ever recorded, 1.66 milliseconds shorter.
So yeah, it's this trend of consistently shorter days that has scientists paying close attention. It's not just random fluctuation anymore.
Okay, so even though we don't notice it, for anything needing super high precision, this matters.
It absolutely does.
So the big question then is, why? What's actually making the planet spin faster? You'd think maybe something huge, but it sounds like it's a mix of things.
That's right. It's a combination of factors. There are the natural influences we sort of expect, like the moon's gravity. It generally puts the brakes on Earth over long timescales through tides.
Right. I remember hearing days used to be much shorter, like billions of years ago.
Exactly. Maybe around 19 hours. The moon was closer then. Its braking effect was stronger. So this current speed up is kind of going against that long-term trend.
Interesting.
What else? Well, there are seasonal shifts, think snow and ice moving around, atmospheric pressure changes. And then deep inside the Earth, the molten core is constantly turning. That affects the spin, too. Oh, and the oceans and atmosphere sloshing around. Even that has a small effect.
Okay, so lots of natural wobbles.
Yeah.
But you mentioned something closer to home.
Yes, and this is where it gets perhaps more surprising, maybe even a bit counterintuitive. Some studies are suggesting human activity is now part of the equation, climate change, specifically the accelerated melting of ice sheets at the poles.
Melting ice makes the Earth spin faster. How does that work?
Think of a figure skater spinning. When they pull their arms in, they spin faster, right?
Yeah.
It's about changing their moment of inertia, how their mass is distributed relative to their axis of rotation. As massive amounts of ice melt and the water flows towards the equator, it's subtly changing Earth mass distribution. It's like the Earth is pulling its arms in slightly, changing its moment of inertia, and that causes it to spin just a tiny bit faster.
Wow. Okay, so it's not just one thing then. It's the moon, the core, the oceans, and potentially us with climate change all mixed together.
Pretty much. It's this complex interplay of all these forces, natural and now human influenced, that seems to be causing this overall acceleration we're observing.
So, okay, we can't feel it. Milliseconds are tiny. Why should we, or anyone, really care? What's the actual impact?
Right. The impact isn't on your daily schedule, but it's potentially significant for our digital infrastructure. The world runs on incredibly precise time.
You mean like atomic clocks?
Exactly. Atomic clocks. They measure time down to nanoseconds, billionths of a second. They're unbelievably accurate. And Coordinated Universal Time, or UTC, the world's official time standard, it's based on an average of about 450 of these atomic clocks around the globe.
And everything uses this UTC, right? Like my phone's GPS.
Your phone, GPS, satellites, financial markets, internet servers synchronizing data, even communicating with space probes, they all depend utterly on UTC's precision.
Okay, so if the Earth's actual rotation, the real length of a day, starts drifting away from the super steady time kept by atomic clocks, I can see how that might cause issues.
Precisely. Even tiny discrepancies, if they build up, could eventually cause problems for systems that need that perfect synchronization. We haven't seen huge issues yet, but the potential is there.
So what's the solution if the Earth keeps speeding up?
Well, this is the really interesting part. If this trend continues, scientists are seriously discussing having to do something unprecedented. They might need to introduce a negative leap second.
A negative leap second. Usually they add one occasionally because the Earth was slowing down, right?
Exactly. Historically, Earth's rotation was gradually slowing, so we'd add a leap second every few years to keep UTC aligned with astronomical time. But now, if the Earth is consistently faster, we might need to subtract a second from UTC to keep it in sync with the planet's actual rotation. The discussion is around potentially doing this by 2029.
Removing a second from time itself.
Yeah.
That's mind-bending.
It really is. It highlights this incredible link between, fundamental planetary physics and the technology that underpins modern society.
It really makes you think, doesn't it?
Yeah.
How much we rely on this unseen, assumed consistency of the planet, of time itself.
We build these hyper-accurate systems, assuming a certain stability, and then we find the Earth itself has other ideas.
And what happens when even these fundamental things start to shift, even by tiny amounts? A fascinating thought to leave with. Thank you for joining us on this deep dive. Thank you.